When we look at chronic illnesses like heart disease and type 2 diabetes, modern medicine usually points the finger at two main culprits. The first is the genetic code we inherit from our parents. The second is the daily lifestyle choices we make as adults. DNA plus adult lifestyle equals adult health. But researchers eventually found groups of people that this standard equation couldn't explain. Despite having nearly identical genetics and adult habits, some groups suffered vastly higher rates of metabolic disease than others. Understanding these outliers required doctors to look backward to a specific, devastating chapter of the Second World War. The Netherlands, the winter of 1944. A Nazi blockade deliberately cuts off food supplies to millions of citizens. The sheer cruelty of this starvation tactic inadvertently created a unique opportunity for scientists to study health across multiple generations. During this blockade, daily rations were slashed to fewer than 1,000 calories per person. For months, adults survived on little more than a couple of potatoes, a few slices of bread, and water. This meant thousands of pregnant individuals endured intense physiological stress and severe malnutrition right as their babies were developing. 60 years later, in the early 2000s, doctors tracked down those specific individuals, the babies conceived during the famine, to evaluate their health as adults. This chart shows the result. Individuals conceived during the hunger winter had vastly higher rates of obesity and diabetes compared to babies conceived before or after the blockade. Siblings born after the famine showed baseline rates of disease, despite sharing the same genetics. Adult health is clearly driven by more than just DNA and habits. The environmental conditions inside the womb leave a biological fingerprint that dictates how our bodies function decades down the line. This data revealed a biological mechanism scientists now call fetal programming, or the developmental origins of health and disease. We used to think of the womb as a passive incubator, where a baby simply grows. In reality, it is an active information superhighway. A developing fetus is constantly sampling its mother's environment, using that data to anticipate what the outside world will be like. Biologists call this predictive adaptation. The food a mother eats and the stress she experiences are translated into chemical signals. These molecules flow directly across the placental barrier, carrying precise environmental data into the fetal bloodstream. During the Dutch hunger winter, severe maternal starvation sent a very clear signal. It gave the fetus a grim weather forecast. The world you are about to enter is freezing, harsh, and completely devoid of food. In response, the developing body triggers an ultimate survival mode, a biological state known as the thrifty phenotype. The fetus actually alters the physical construction of its own internal organs. It optimizes its liver and pancreas, wiring them to aggressively capture and hoard every single calorie they encounter. These babies were not born damaged. They were biologically engineered to survive a lifetime of starvation. But that biological engineering creates a dangerous situation. What happens when a body built for a famine is born into a world where the famine ends? As these cohorts grew up, Europe rebuilt. The starvation of the 1940s was rapidly replaced by the modern, high-calorie food environments of the post-war decades. This caused a physiological collision. A body wired to relentlessly hold on to fat will quickly overload its metabolic systems when it is suddenly surrounded by abundant, easily accessible fast food. That sudden influx of calories overwhelms a system optimized for scarcity, driving the rapid onset of heart attacks and type 2 diabetes by the time these individuals reach middle age. Their illness was a survival strategy that tragically received the wrong weather forecast. This requires us to rethink how we view human genetics. DNA is not a rigid destiny, carved in stone the moment of conception. During gestation, the genetic code is highly malleable. Fetal programming shows us that our DNA is a flexible script. The womb's environment actively edits that script before we even take our first breath. This reframes prenatal care as the earliest possible intervention against adult metabolic disease. It also suggests we should stop blaming chronic conditions like obesity and diabetes entirely on an individual's lifestyle choices or perceived moral failings. By supporting and nourishing pregnant individuals, we directly influence the long-term health trajectory of the next generation. Recognition of this invisible inheritance allows us to address the roots of disease before they even begin.